Alright, so let's work through the A2 mock then. So question 1 is all about small angle formulae. So if I write those down first, we've got sine theta approximates to theta, tan theta also approximates to theta, and cos theta approximates to 1 minus theta squared over 2. What a lot of you got wrong was cos theta is 1 minus theta squared, so whatever the angle is here, it has to be squared here. So we have to rewrite 1 minus cos 4 theta over sine 2 theta sine 3 theta. So the cos 4 theta is going to become 1 minus 4 theta squared over 2. Oops, there's another one there. Let's do that again. 1 minus 4 theta squared over 2. All over 2 theta, and sine 3 theta is going to become 3 theta. So 2 theta times 3 theta. So if we try and simplify this, the denominator, or if we keep the numerator, say 1 minus 1 minus, put brackets there, 16 theta squared over 2, all over 6 theta squared. Now if we sort out the numerator, the 1 and the 1 are going to cancel, so we're going to be left with minus and minus, which is plus 16 theta squared over 2 over 6 theta squared. 16 over 2 is 8, so 8 theta squared over 6 theta squared. Theta is going to cancel, leaving us with 8 over 6, which we can simplify to 4 over 3. So that's that one. Question 2 is all about differentiation and stationary points. So a bit of second or first year content in this one. So y is x squared minus 2x minus 24 x to the half, so changing my root into power half there. Dy dx is going to be 2x minus 2 minus 12x to the power minus half. So next bit we need to find the second derivative. So d2y by dx squared. So that's going to be 2 plus 6x to the minus 3 over 2. Right, so next it asked us to verify that it has a stationary point when x is 4. So stationary point is when the gradient is 0. So if you put in x equals 4, the gradient should become 0. So 2 lots of 4 minus 2 minus 12 lots of 4 to the minus half. So we're going to get 8 minus 2 minus 4 to the minus half, then so that's the square root of 4, which is 2, and then reciprocal it, so 1 over 2. So we end up with 12 over 2. So 8 minus 2 minus 6, which is of course 0. So hence stationary point. Remember, proof, you've got to have your statement and proof at the end. Alright, next it asks us to determine the nature of the secondary point. So remember, nature of secondary point is it a minimum, a maximum, or a point of inflection? And the way we test that is with the second derivative. So if we substitute 4 into our second derivative and see what the sign of this comes out as. So d2y by dx squared equals 2 plus 6 lots of 4 to the minus 3 over 2. So that becomes 2 plus 6 times, again, 4 to the half is 2, so square root 4 to get 2. Then we could cube the 2 to get 8, then reciprocal, so 1 over 8. So end up with 6 over 8 there. So that is 2 plus 6 over 8, which gives us 22 over 8, which is of course positive. Therefore, it is a minimum. Cool, right, on to question 3. So this is all about trigonometry, looking at area of different shapes. Cool, so again, the key equations here, we know the arc length L equals r theta. Remember, only when it's in radians, not that that's relevant here. And the sector area is half r squared theta. So a lot of you hadn't learned those, which is why you got this wrong. Okay, so we're told the area is 11. So we can say 11 equals half r squared theta. The next bit of information we're given is that the perimeter is 4 times the arc length, so 4L. So if we find an expression for the perimeter based on what we know about this shape, set that equal to 4 times the arc length using r and theta, we can then substitute it into this and find our value for r. So the perimeter of this shape is going to be r plus the arc length, which is r theta. And we know that perimeter is equal to 4 times the arc length, and the arc length is r theta, so 4 r theta. So I've basically got 2r plus r theta equaling 4r theta. If I take take r theta from each side, we get 2r equals 3r theta. Divide both sides by r, and we get theta equals 2/3. So if we want to find r, we can just put that back into our area equation and work out what r is. So 11 is going to equal half r squared times 2/3. So 22 equals 2/3 of r squared. So 33 equals r squared. So r equals the square root of 33. Which has to be positive because we're talking about a radius. The next one is, again, looking at differentiation. So differentiating trig, and it looks like we're going to have to use the quotient rule. So we're trying to show that dy dx is this function here. So we've got u on top, v on the bottom. So u equals 3 sine theta, v equals 2 sine theta plus 2 cos theta. So we're going to differentiate each of these and put them into our quotient rule equation, which hopefully you remember. Dy dx equals v du dx minus u dv dx over v squared, which is given to you in the formula book. So u dash du dx is going to be equal to 3 cos theta, v dash is going to be equal to 2 cos theta, and then that's going to differentiate to minus 2 sine theta. So if you put all these bits into the equation, we get dy dx equals v du dx. That's going to be 3 cos theta, 2 sine theta plus 2 cos theta minus u dv dx. So multiply these two together. All divided by v squared, v being this, so 2 sine theta plus 2 cos theta all squared. So all we need to do is simplify this and find out what a is when we get it down to this form. So if I expand all the brackets on top and the bottom in one step, we're going to get 6 sine theta cos theta plus 6 cos squared theta. Take 6 sine theta. So if I expand both sides of this, or both terms in that, I get 6 sine theta cos theta plus 6 cos squared theta minus 3 times 2, so 6 sine theta cos theta plus 6 sine squared theta. And that's all going to be divided by so expand this one, so 4 sine squared theta, so 2 times 2, 4, so 8, plus 8 sine theta cos theta plus 4 cos squared theta. Alright, so we've got some cancelling to do. So you should be able to spot we've got sine squared plus cos squared there, so that's going to be something. And these two terms just cancel each other out. So the next line is going to give us 6 sine squared theta plus 6 cos squared theta all over 4 sine squared theta plus cos squared theta plus 8 sine theta cos theta. Cool, so we can factorize out our 6's and our, oops, left out 4 there, plus 4. Just factorize out our 4's and our 6's in these two terms, and this is going to be a double angle formula. So 6 lots of sine squared plus cos squared over 4 lots of sine squared plus cos squared plus, so we've got 4 sine theta cos theta. The double angle formula is sine 2 theta is 2 sine theta cos theta. So we've essentially got 4 lots of this here. So we're going to get 4 lots of 2 sine theta. Sorry, 4 lots of sine 2 theta. So there we go. So these brackets both become 1. So we get 6 over 4 plus 4 sine 2 theta. And now we can just divide the top and the bottom of this fraction by 4 in order to get it into this form. So we get 6 over 4 over 1 plus sine 2 theta. So a is 6 over 4, which of course simplifies to give us 3 over 2. Cool. Question 5. This is one of the more difficult questions, especially the last part of it. So we've got a circle, we've got a tangent, and we're trying to find the equation of the line from P to A. So we're trying to find a normal, basically. So first thing we need to do is find the gradient of the line AP. So because it's a normal compared to our tangent here, it's going to have the negative reciprocal gradient of the tangent. So tangent is this line. So tangent gradient is 2. So the normal is going to be minus a half. So there's a gradient for our line. We know the point, which is the centre of the circle, 7, 5. So we can put that into our line equation and work it out that way. So y minus 5 equals minus a half x minus 7. And we can just expand this and find our line equation. So y, 2y, take 10 equals minus x plus 7. So add the 10, add the x. So 2y plus x equals 17, which is what we need to prove. Right, what are we told next? So we want to try and find the equation for the circle. Well, these two lines, the one they gave us and we found, meet at a point on the circle. So if we find that point, we can then find the length of the radius, and we already know the centre of the circle. So if I solve these two simultaneously, we'll get 2x plus 1 as y. So 2 lots of that plus x equals 17. So 4x plus 2 plus x is 17. So 5x equals 15. So x equals 3. I can sub that back into either of these to find y. So if I put them back into the equation, they gave us 2 lots of 3 is 6 plus 1 gives us a y value of 7. So point P has coordinates 3, 7. So find the length of the line between these two. That's my radius, and then we're good to make our circle equation. So length of line, length of the radius is going to be 5 minus 7 squared plus 7 minus 3 squared, all square rooted. So we get 2 squared plus 4 squared, which is going to be 4 plus 16, which is going to give us a radius of root 20. So if we put this all together, we get x minus 7 squared plus y minus 5 squared equals the radius squared, which is going to be 20. Right, here's where it gets a bit more difficult. So we're told that another line, which is y equals 2x plus k, where k is not equal to 1, is another tangent to this circle. We're trying to find the value of k. What you need to remember is that a tangent meets a circle in exactly one place. So if we solve these two simultaneously, the quadratic we get will only have one solution. Therefore, the discriminant of the quadratic we get when we solve these simultaneously will be equal to 0. So I'm going to solve them together, solve it simultaneously, find the discriminant, and that will give me my value for k. So x minus 7 squared plus 2x plus k, so I'm literally just subbing y straight into there, minus 5 squared equals 20. So if I expand this quadratic, I'm going to get x squared minus 14x plus 49 plus 4x squared plus 4x times k minus 5 plus k squared, expanding this bit now, minus 10k plus 25 equals 20. So we just need to simplify this, find a, b and c, and then use the discriminant. So if you work your way through this, it simplifies down to give you 5x squared minus 34x plus 4xk plus k squared minus 10k plus 54 equal to 0. So we've got a quadratic equal to 0. A is going to be 5. B we're going to have to work out by factorising the x's out of this stuff. And C is going to be all this stuff in the end, all the stuff that doesn't contain an x. So if I factorise these two terms, 5x squared plus x times minus 34 plus 4k plus k squared minus 10k plus 54 equals 0. So A is 5, B is minus 34 plus 4k, and C is k squared minus 10k plus 54. So we're going to put all this into the discriminant, which will give me b squared minus 4ac, so minus 34 plus 4k squared, b squared minus 4 lots of a times c, and the discriminant should equal 0 because that's the condition for having one root as a solution to our quadratic. So if we solve the discriminant, we're going to find k. So I'll expand all that, and you end up with minus 4k squared minus 72k plus 76 equals 0. And if you factorise that, you could divide through by 4, or you can get a calculator out. You get k equals 1 or k equals minus 19. 1 is one of the solutions, but we were told at the beginning k cannot equal 1, so that rules out that solution. So therefore k must equal minus 19. Okay, so next up was this integration question, which sounds quite hard, but if you just do it, the results kind of fall out of it. So as long as you're not scared of trying it, it's not actually that bad. So we need to show that the integral of this, when you put the limits in, is independent of k. All it means is the answer probably won't have, or shouldn't have a k in it, and here we got inversely proportional to k, which means the answer will be a constant over k. So the first integral is a standard log kind of integral. So k to 3k, 2 over 3x minus k dx. So if we integrate that, we're going to get log of 3x minus k. Think about differentiating this to check. So if you differentiate this, you would get 3x minus k on the bottom, but you get 3 on the top. We've got a 2 on the top, so we need to divide by our 3 and times by 2. So there's the integral done. Put the limits in, so k and 3k. Remember to show all of this, so 2/3 of ln 9k minus k minus ln of 3k minus k. That's going to become 2/3 of ln of 9k minus k is 8k, divided by 3k minus k is 2k. So our answer is going to become 2/3 of log 4. No k's to be seen, therefore independent of k. Second one, similar idea to it really. So but slightly different integral. So we've got 2k, k, 2 over 2x minus k all squared, dx. The trick to these is spotting that it's definitely not log. Log only works when it's a power 1 on the bottom. Otherwise, it's going to be a different method. So there's a couple ways that we can approach this. I think the easiest way is to just use like a first year kind of integral. So we're going to bring this up with a negative power. So 2 lots of 2x minus k to the minus 2. If you integrate, remember the power is going to increase, divide by the new power, and then use reverse chain rule to work out what happens in the middle. So we're going to get 2x minus k to the power minus 1. Divide by minus 1 is going to give us a minus 2 out the front. But if we differentiate this, we get that 2 anyway. So we don't need a 2 there. So we're just going to get minus 2x minus k to the minus 1. So if we write that out again with our limits, minus 2x minus k to the minus 1, 2k and k. And we'll evaluate what this is. So we get minus 4k minus k to the power minus 1. Take away the other limit, which is going to be minus minus, so plus 2k minus k to the minus 1. So we get minus, so we get minus 3k to the power minus 1 plus k to the power minus 1. So that becomes minus 1 over 3k plus 1 over k. So you can think of this as 1 take a third, and then k just ends up on the bottom somewhere. So 1 take a third is obviously 2 over 3 with k on the bottom, which is therefore inversely proportional to k. So we've got our equation of this ellipse, which would be described parametrically, and we want to try and find the differential. So we're trying to differentiate x squared minus 2xy plus 3y squared equals 50. So we're going to be using implicit differentiation. So the first term, easy, x squared differentiates ev 2x. Next term, we've got a product of x and y. So we need to use the product rule on this. So we're going to get minus 2x times the differential of y. So that's minus 2x dy dx plus the differential of 2x times by y. So 2x differentiates to 2, so we just get minus 2y for that term. 3y squared is going to give us 6y dy dx, and 50 is going to differentiate to give us 0. So there's our differential. We just have to rearrange and show that it can be rearranged to give us this. So we get all my dy dx terms on one side, all my other terms on the other side. So if we say 2x minus 2y equals 2x dy dx minus 6y dy dx, factorize out the dy dx terms. So 2x minus 2y equals dy dx 2x minus 6y. Divide down to get dy by dx is 2x minus 2y over 2x minus 6y. All this is divisible by 2. We actually want to divide it by minus 2 in order to get the y's positive. So if I divide it all by minus 2, dy by dx equals y minus x over 3y minus x. Okay, then it gets rather difficult if you don't know what's going on in the picture. So using this answer, find the exact coordinates of the point P. So what do we know about point P? Well, if you look closely, we have got a asymptote at point P. So, and we just did a differential, so we have to start thinking, what is the gradient of an asymptote? Obviously it's straight up, so the gradient is approximately infinity. So we can say dy dx is roughly infinity, or it tends to infinity, but our solution for when it equals infinity is going to be the same as the x coordinate for point P. So to make something equal infinity, the easiest way is to set the denominator equal to 0, because dividing by 0 gives you infinity. So 3y take x equals 0, therefore x equals 3y. So if we put this back into our original equation and solve it, we'll be able to find our x and y coordinates for this point. And this point as well, actually. So x squared is going to become 3y all squared minus 2 lots of 3y times y plus 3y squared equals 50. So I'm solving this for y. You could equally just as easily solve it for x if you wanted. So 9y squared minus 6y squared plus 3y squared is 50. So we're going to get 6y squared equals 50. So y squared is 50 over 6, which is the same as y squared is 25 over 3. So y equals plus or minus 5 over root 3. If you rationalise the denominator to make it a bit more proper, we say y is plus or minus 5 root 3 over 3. Now we want point P, so we want the negative one. So our y value is going to be minus 5 root 3 over 3. And we can sub that back in to find x. So x equals 3 times y. So x is going to be minus 5 root 3, because if you times that by 5, times it by 3, you just get rid of the 3. So as a coordinate, minus 5 root 3, comma, minus 5 root 3 over 3. Right, next up is question 8, which is our method question. So first thing it wants us to do is work out or use separation of variables integration in order to find what h equals. So we're going to split all the variables up, get h's on one side, get all the other bits of tn on the other side, and then integrate both sides. So dh by dt is h cos 0.25t over 40. So if I get all the h's over here, we're going to get 1 over h. I suppose we could times it by 40 as well to get 40 over h dh equals cosine of 0.25t dt. So integrate both those sides. So on this side we're going to get 40 ln h equaling cos integrates to give us sine 0.25t, and then use reverse chain rule to check what you get out the front. So if you differentiate, you would get 0.25 out the front, which is a quarter. We don't want a quarter, so we need to times our answer by 4 and put plus c. Alright, so they told us that the passenger was 5 meters above the ground at the start. So when t is 0, h is 5. And that's going to let us find our constant of integration. So 40 ln 5 equals, well, sine of 0 is 0, so that's just going to equal c. So our equation is going to become 40 ln h equals 4 sine 0.25t plus 40 log 5. So if we use log rules first and subtract both these from each other, 40 ln h minus 40 ln 5 equals 4 sine 0.25t. If we divide everything by 40, we get ln h minus ln 5 equals 1 over 10 sine 0.25t. Log division rule there, so we get ln h over 5 equals 1/10 sine 0.25t. Call that 0.1 because that's what they've done in the question. So and we're going to e both sides. So h over 5 equals e to the 0.1 sine of 0.25t times by 5. H is 5, e to 0.1 sine of 0.25t. Cool, so we've shown it. Next bit, state the maximum height of the passenger above the ground. So if we look at our h equation, we want to try to find out what the maximum value of this is. So let's just have a quick think. E as a graph just increases. So our maximum E value is going to be given by our maximum value we put in, and the value we put in is going to be to do with this. So we've got a sine graph. Now sine's maximum is a 1, so 1 times 0.1 is 0.1, so our maximum is going to be when h equals 5e to the 0.1, and if you type that into a calculator, you get h equals 5.53 meters to 2 decimal places. So that's our max height. Okay, next one, question 9. So we're doing binomial expansion. So trying to show that 1 plus 4x over 1 minus x is roughly equal to 1 plus 5 over 2x minus 5 over 8x squared. So we need to use binomial expansion on the numerator and denominator, use surds to split this up, expand everything, and hopefully we'll get to this. So we can say this is 1 plus 4x to the half over 1 minus x to the half, just by using some surd manipulation. We can then bring this fraction up, or bring this denominator up, to make it 1 plus 4x to the half times by 1 minus x to the minus half. So we expand both of these binomially, times them together, we should get that. Now we only go up to x squared, so I'm only going to bother expanding these up to the x squared terms, so we can do it pretty quickly. So 1 plus n, which is a half, times 4x plus n times n minus 1 times 4x squared, 4x all squared over 2 factorial. So that's the first one. Second one is going to become 1 plus minus a half times minus x plus minus a half times minus 3 over 2, I got room there, times 4x, not 4x, minus x all squared over 2 factorial. So I've expanded both. We'll just simplify both of these. So if you work those through, you should get 1 plus 2x minus 2x squared for the first expansion, times by 1 plus x over 2 plus 3 over 8x squared for the second expansion. So if we times these out and cancel it down, you should end up getting 1 plus x over 2 plus 3 over 8x squared plus 2x minus 2x squared plus x squared, which does simplify to give you 1 plus 5 over 2x minus 5 over 8x squared, which is what they wanted. Right, last bit of this question is asking why shouldn't the student use a substitution of x equals a half? And we've got to look at the limits that it's allowed for. So remember, binomial is valid for x is less than 1, where x is whatever the second term of our brackets is. So if we say for the first one, we're going to get modulus of 4x has to be less than 1, and for the second one, modulus of minus x or modulus of x has to be less than 1. So if we simplify this one, we're going to get modulus of x has to be less than a quarter, which is a smaller range than this one. Half is bigger than a quarter, so you're not allowed to use it. So we could say a half is greater than a quarter, so not valid for this x value. Right, next up, question 10, which is a bit of a mix, this one actually. So first bit is kind of a similar method that we've used in our geometric series. So we're told initial value of the car after t is at years after 1st of January 2001. So let's use that first of all. So the value, or even the t is going to be equal to 0 when the year is 2001. So this is going to be important for later. So our first t value is going to be the year 2002. If you look in the question, they told us the value of the car on the 1st of January 2005. So 2005 is going to correspond to a t value of 4. And later on the 1st January 2012, it's going to correspond to a t value of 11. So you've got to be careful, make a little table so you know exactly what t value you need to substitute into the equation. So if we use our two values they've given us, 32,000 when t is 4 and 50,000 when t was 11, we can get two equations and solve them simultaneously. So the value 32,000 equals a p to the power 4 and 50,000 equals a p to the power 11. So if we divide these, we can work out what p is. So it'd be better to do this other way around actually. So if I write this one underneath, 32,000 equals a p to the 4. So if you divide these two, 50,000 over 32,000 is just going to simplify to 50 over 32. A divided by a cancels. 11 divided, p to 11 divided by p to the 4 is going to give us p to the 7. So p is going to be equal to the 7th root of 50 over 32. Which if you type into a calculator and round it to 4 decimal places, you get a value of 1.0658 for p. Right, so we can use that value to find a. So we're going to substitute this back into either of these equations. So 32,000 equals a times 1.0658 to the power 4. So divide by that to get a, and you should find that a equals 24799.74, which is approximately 2,800 if you round it up. Right, so now we need to reference our model as to what a and p actually are. And this is a callback to a log to linear form question. Remember when changing a kind of exponential question into a log equation and then comparing it to a straight line to work out what these are. So the way to do that, v equals a p to the power t. We're going to log both sides to get log v equals log of a p to the t. Use log rules to split this up. So log v equals log a plus t log p. So if we look at this, our x value is obviously time, y value is log v. This is going to be our y-intercept, and log p is going to be our gradient. So if we look back at the question, we can interpret what these things actually mean. So let's do log a first. So a is going to be our y-intercept, which is going to be the value of the car on the 1st of January 2001. So value of car on 1st Jan 2001. P is going to be the gradient, and for the gradient we've got a value of, what was it again? 1.6058. So P is the factor by which the value rises each year. So you needed to be specific in detail for that. It needed to be a factor or a rate by which the value rises each year. So specifically linking it back to the question. Right, part C, find the year during which the value first exceeds 100,000. So we're going to say 100,000 is less than our value, which is a p to the power t. So that's 24800 times 1.0658 to the power t. So we can use some logs to solve this. So if we divide by 24800, we're going to get 125 over 31 is less than 1.0658 to the power t. Log both sides, or learn's a bit quicker to write. 125 over 31 less than t ln 1.0658. So I've logged it and then used the power rule. Divide both sides by this ln to get t is greater than 125 over 31 divided by ln 1.0658. If you type it into a calculator, you get t has to be greater than 21.88. So it's during this year. So if we look back at our table of values, which I've lost, there we go. RT value 21.88, which is going to be during the year 2022. So this corresponds to this year. So when it's greater than this, it's going to happen before the end of this year. So our answer is going to be 2022. Reason we're not rounding up to 2023, it says the year during which. So it's during this year it happens. 2023 is too far. It's at some point this year that the value exceeds 100,000. Right, last question is a kind of open-ended integral question. So there's a couple different ways. If you do this by parts, you could do this by substitution. I'm going to do it by substitution just because I think that was the method that most of you decided to use. So we're integrating 0 to 2, 2x, root x plus 2, dx, and we're trying to get 32 over 15, 2 plus root 2. So I'm going to get u equal to x, dv dx equal x plus 2 to the half. So dv and u, it doesn't actually matter which way you pick them for this. I think substitution might be quicker. If you let the substitution equal the x plus 2, it's pretty straightforward. So du dx is going to equal 2, and v is going to be the integral of this, which is going to give us x plus 2 to the 3 over 2 divided by 3 over 2. So our by parts equation, uv minus integral of v du dx. So this is going to become 4 over 3 x times by x plus 2 to the 3 over 2, subtract the integral of 4 over 3 x plus 2 to the 3 over 2 dx. So if you integrate this, we're pretty much done. So 4/3 x plus 2 to the 3 over 2 minus 4/3 times 2/5 x plus 2 to the 3 over 2. So that's our integral. Let's simplify that quickly and then we'll put the brackets around it. So 4 over 3x, x plus 2 to the 3 over 2, minus 8 over 15, x plus 2, 3 over 2. And our limits are 0 and 2. So you need to put these in and show that we've done both limits. So 4/3 of 2 times 4 to the 3 over 2. Take 8 over 15 of 4 to the 3 over 2. Subtract. First term is times by x, so it's going to be times by 0. So the first term becomes a 0. Subtract 8/15 of 2 to the power 3 over 2. Right, let's do this by hand. So, yep, sort these out first. So 4 to the power 3 over 2, well, the 2 there is going to be a square root, so that's going to be 2 cubed. So we're going to get 8 over 3 times by 8. Subtract, again, 4 to the power of that is going to be a root, so that'd be 2. 2 cubed is, again, oh, I've done something wrong here. Yep, that power should be a 5, and there, and there, and there. Yeah, cool, right, sorry about that. So yeah, 4 square root is 2. 2 to the power 5 is going to be 200 and... no, it's not. 32. So if we times that out by 8 over 15, we're going to get minus 256 over 15. All subtract, or plus now, 8 over 15 times 2 to the 5 over 2. So square root are 2, you can't do that. So if we leave this as, we could 2 to the 5 and then square root the answer. So if you turn it into a calculator, you end up with 8 over 15 times 4 root 2. So getting somewhere now. So we're going to get 64 over 3 minus 256 over 15 plus 32 root 2 over 15. Find a common denominator for this one, so we need to times the top and bottom by 5. So we're going to get 320 over 15 minus 256 over 15 plus 32 root 2. I guess you could do this on a calculator, but where's the fun in that? So subtract these two, we get 64 over 15 plus 32 over 15 root 2. Take out factor of 32 over 15. We get 2 plus root 2, which is what they wanted us to get up there. Cool, right, that's it. Let me know if there's anything you still don't understand. Yeah, cool, cheers.